Hello everyone, welcome back to the channel. Today we're going to talk about dbt, which shortened for Data Build Tool. In the world of data warehousing and analytics, we are familiar with ETL and ELT process. Both of them are responsible for data extraction, transformation, and loading the data into data warehouse. dbt is part of ELT, and dbt is the T in there, which means it takes care of the transformation of ELT process. dbt executes transformations via SQLs, which allow users to write SQL queries that transform data and create reproducible workflows that can be easily tested and automated. dbt is specifically designed for the modern data stack architectures, and it works well with the platforms like BigQuery, Snowflake, Redshift, Azure Synapse Analytics, and others. In short, we can say that dbt is the data transformation tool that enables data engineers and analysts to perform transformation in warehouse. Now we understand that dbt's core functionality is the transformations, or we can say the power of dbt lies in the transformation. It's important to understand its limitations too, or in simple words we can say what dbt can't do. dbt is not an ingestion tool, so it's not a data ingestion or data loading tool. There are other specialized tools which perform the data ingestion or loading into the data warehouse. It's not a BI tool either, and dbt does not store data. The data which it's transferred, it actually resides within your data warehouse. So it's not like a storage where you will pull the data, do the transformation, and store it back to data warehouse. No, it doesn't work like that. The data is stored in the data warehouse. dbt does not have its own storage. And the last is, it does not function as a compute processing unit. So the computation required for that transformation is performed by the data warehouse, not by dbt itself. So if we compare this with Spark, for example, Spark is also used for processing the data, but Spark have its own processing units, because with Spark we can spin up a cluster with its executors and drivers and all. So it have its own processing units. But with dbt, that's not the case. In dbt, the computation, whatever computation dbt required, comes from the warehouse on top of which dbt is running. Now look at the dbt products. So dbt are primarily offered in two forms. The one is like dbt core and the other is dbt cloud. dbt core is just basically a collection of open source Python packages which we can execute via command line, and that helps in like transformation, documentation, testing, and all those things which dbt is capable of. On the other hand, the dbt cloud, it's basically a web-based UI which allow us to both develop and deploy our data pipelines within the dbt itself. And but it's basically, if you think like it's built on top of dbt core. So in terms of functionality, dbt cloud is pretty same. It's basically a web-based product, or you can say it's the cloud version of dbt core, and with more functionalities such as you can schedule your jobs, you can like it have its own IDE, like where you can code your things. It can integrate with your GitHubs and all that we will see in the demo. And the important thing to know about dbt cloud is like it's free for basic usage, but if you want to go for an enterprise or like several users, then you have to pay. And if you ask me which one a company should use, dbt core or dbt cloud, so dbt core is for somebody who want to manage their infrastructures and have control a lot on their architecture and all. dbt cloud is where like they don't want to do the maintenance and all those kind of activities. That will be handled by dbt team. And for a user, It could be a personal choice, like it could be people can go for dbt core or dbt cloud. In dbt core will be a basic Python package which you install using pip install, but with dbt cloud it's few clicks. You can spin up your cloud dbt and integrate with whatever data warehouse you want. So it's personal preference, but depending on but in terms of functionality, they works pretty same. dbt cloud have more functionalities. That's the major difference between them. Now we understand like what is dbt, what dbt is not. Now let's try to understand like where dbt fits in the data lifecycle. So in the data lifecycle, the data from the various sources, you can see on the left side, data from the various source is loaded into data warehouse. That could be anything. At the top you can see it could be Snowflake, Redshift, or Azure, Snapshots, or BigQuery. So data is ingested using data loaders or specialized tools which can load data in the form of raw data, and then after the data is loaded into the data warehouse, then comes the dbt. dbt transform this raw data into a, you can say into a like a refined business ready formats based on the business rules or the logics for transformations are used and stored back within the data warehouse. So data was loaded from the data loaders as a raw, then dbt transform the data based on the business rules and make it more user friendly and store back into the data warehouse. And subsequently these transformed data become accessible. Like after that it can be used in reporting or it can be consumed by other data consumers. So if we think from the data lifecycle perspective, like dbt sits with the data warehouse, it has where like it's responsible only for transformation. It's not responsible for the ingestion and all those pieces, ingestion or loading the data, and it's also not responsible for like BI tools and those kind of things. And as we mentioned, dbt when it transform, it use the computation power of data warehouse. It is not it does not have its own computation power. As of this video is reporting, dbt support wide range of data warehouse or data lakehouse. You can check that on let me share the link. We have a link, give me 1 second. If we go, we can check what data platforms are supported on this link, and at the time of recording of this video we can see there are like bunch of data warehouses or data lakehouses are supported. So one is OllyDB, BigQuery, Databricks, Dermero, Postgres, Redshift, Snowflake, Spark, Trino, Microsoft Fabric, Azure Synapse Analytics, Teradata. Bunch of them are there. And if you wanna keep checking like what are the new databases or like which data sets are compatible with dbt, please visit this official page where you get the list of all the compatible data warehouses. Now we know what is dbt and where it fits in the data lifecycle. Let's look into the core concept of dbt. In this slide, we are discussing these concepts at higher level, but we will explore all these concepts in next few minutes. We'll start with models. Models is the basic building block of dbt. A model is essentially a SQL file with a select statement. These models are defined in .SQL files and can be referenced by other models and tables within the data warehouse. Next, we'll move to macros. We can think macros are pretty same as the functions in Python. So what that means is basically if we want to use a code again and again, we define a function in Python. So similar concept for the macros. When we want to use a SQL code across various models or in different places, we can write a macro. Then comes the next concept is the test. Test with dbt is basically to verify the data quality of your models. And there are two types of friendly tests are available in DBT, generic and singular. Generic also break down into 4 tests, and singular is more customized. We will look into them in details in the next few minutes. And the last core concept is a snapshot. Snapshot is basically to track the slow changing dimensions over time. And here DBT is handling only slow changing dimension type 2. There are other slow changing dimensions, but DBT takes care of only slow changing dimension type 2. And on the left side, we can look at the DBT project structure. So when we initiate a DBT project, the DBT project structure will look like as we can see on the screen. So a DBT project is generally, as we can observe, consists like various files and folders, and few of the folders are very obvious, which we can see from the core concept, like models is snapshot, test, and macros. There are like few more folders. There are like seeds, analysis, but we'll explore all of them when we start hands-on with the DBT project. But this is the general, or you can say the initial DBT project structure. Now let's explore the process of setting up DBT Cloud with BigQuery. This exercise has some prerequisites. So you need to have a GCP account, a project within the GCP, a BigQuery setup, or you can say the BigQuery API should be enabled, and a GitHub account for versioning control of your code. The step 1 is to have a DBT Cloud account. So for that, let's go to the DBT page. Okay, so once you land on the DBT page, like they provide you an option to create an account and a free account. So as we discussed before, like for a single user, you can create a free account, but if you are an enterprise or multiple users, then you can't create a free account. But for a demo or for learning purposes, free account is good enough. So if you haven't, so here, like once you land here, you need to register yourself and sign up for the DBT Cloud account. I have already registered myself, so I'm not going to do that. And it's a very simple process. You can do that. After that, like after the sign up complete, you need to log in into DBT and set up a project. So let me go, here, 1 second. So once you log in, like it says, 1 second, let me close this. I already have a project. So let me do one thing very quickly. Go to profile, click on projects. So no projects here. And you see, if you already have a project, you can set projects here, but I don't have any projects. So I'll, after login, click on your profile, go to projects, or even like it lands on you to the create a new project page. But if you're not able to find it, you just need to click on the setting, then account setting, and then click on profile. So here, click on new project, and it will ask you to give a name to the project. So I'll pick DBT BigQuery training. After that, click on continue. And now we have to select the connection or the data warehouse to which we want to connect. So in our case, we need to do it with BigQuery. So we'll select BigQuery, click next. And now to connect with BigQuery, we're going to use the service account to connect BigQuery with DBT Cloud. But if you are from an enterprise or like this is not the only option, there are other ways to do it. But for this exercise, we will use the service account method. And let me show you how to get the service account JSON, because if you look at here, like rest of the things like is empty, but we have an option to upload a service account JSON file. So at the moment, nothing is in there, but we can get this from BigQuery, and rest of the fields will populate or will be fetched from this JSON file. So let me show you how to get this service account JSON. So for that, first you need to go to your your GCP console, log into that, look for IAM and admin service. Once you are in there, you can see I'm already here, but if you're not there, you can search it here, or you can click from the drop down too, like the way is convenient for you. So I'm already in IAM admin. After that, click on service account, and after that you land here, click on create service account, give a name to a service account. So let's give it dbt, let's say test. Okay, after that click on create and continue. Now we need to give the access to service account. So for learning, I'll give the owner role because it's a demo, as I said, like, and we are not we're not in the production environment, but you feel free to do whatever works for you, but I'm giving owner so we don't get like various permission issues and all. So basically on this step, we need to define the role of our service account. After that, click done. This will create a service account for us. So you can see this is dbt-test, and after that, this is our service account. And at the moment, we don't have any key to it. Once that is created, click on this account, click on keys, click on add key, and create a new key. And here you can see we have two options, either to create this key as a JSON or P12. But if you remember, for dbt cloud, we need JSON. So we'll click on create. This will download a JSON file for you in your download folder. And after that, we can go back to our dbt project one more time. Let me go there. Yeah. So click on upload a service JSON file. So I already have another JSON file which I'm going to use. I already have a service account I'm using. I can use that. And in your case, you just need to go to download and select the recent ones. Okay. In my case, I'm using one of my existing service account. And now you can see once we upload, like, all the fields which were empty are filled with some information. After that, like, everything is there. The things which are optional, we'll keep them as it is. We are not populating them. And after that, if we scroll down, so this section is important to understand, because here you see the dataset name. So the dataset by default name is dbt_akumar. So whatever name you give here, that will become your dataset for dbt in your BigQuery. Okay. So what I mean by that, like, in our BigQuery, datasets are basically are the databases. So if you look here, we have a project ID in our BigQuery. This is our project, and in that project, a dataset will be created with this name. Okay. So what you need to do next is click on test connections just to make sure like everything is working fine. Okay, click next, and in a while we will see like how this dataset, or like how this dataset look into BigQuery. Click next, and the last step is to link your code repository with dbt cloud. So that we can do by two ways. So the one is we can do it here, that because I have already clicked. As soon as I click on GitHub, GitHub is the code repository I'm linking. You will see it's linked to my GitHub account and all the repositories which I have. I can pick which repository I want. I want to connect, but that is like one way to do it. But I'll show you there is another way. If you click on this, go to profile setting one more time, click on integration, and here also you can do this. So here also you can integrate, and you can integrate while setting up the project too. So there are like multiple ways to do this thing, but I'm telling, like, you can pick the way you want to. I prefer the first way because in that way we are, sorry, in that way we go here, cancel, sorry, let me go back to my project settings. Give me 1 second. Yeah, so here, like, I feel it's a choice. You can do the way, like, you can do it from here or there. It's both ways. It's just a 2-click process. In my case, it's already connected, so it's asking me to select our repository. So what I'll do, I'll create an empty like a new repository so we can see how to set up project and all. Let me close this, go here, and let's create a new repository. So I already have 38 repositories. If I want, I can use one of them, but we are doing it for first time, so let's create a new one because I want to show you like with an empty repository how you can initialize your project in dbt and also create the basic structure. So we will give it a name, dbt bq demo. We will make it public, create repository. Okay, so this repository is created, and as you can see there is nothing in this repository. It's blank. We'll go back to our projects, dbt project, and let's search for that, dbt basics bq demo. So this is the repository we created. We click on this, and after that we can start the development of our project. And there is one good thing about the cloud dbt is like it have its own built-in like IDE, and it integrate well with GitHub. So we don't have to go, or we don't have to switch to multiple like multiple tools in it. So now you can see this is our project and it has nothing in it. And here you can see version control is there. There is an option to create a file, and at the bottom we have a like CLI to run dbt commands, which we're going to see in a while. So the first thing we will do, because we know the project was empty, we don't have any structure and all. So what we will do, we can initialize our project. So there are 2 ways to do it. We can initialize our project by clicking on this, or we can literally type a command dbt initialize and project name. So we'll click here just to show you. Once this is done, and you can see a structure which we discussed before, or kind of similar structure is created where we have folders for macro, model, seed, snapshot, test and all. And let's do one more thing. Let's commit and sync this, because these files now we have added, they are not in our main repository, so we will commit it. Let's say we say project initiated, commit the changes. Awesome. So now we have a structure. This is our main branch. We have a structure here, and if we go to our GitHub and just refresh this, we should see all the folders here too. So it's the same folders which we have here is here. So we can see, like, for example, this md readme file, same thing we can see here. Okay, awesome. And another thing is, like, this is GitHub thing, but we can create another branch here, because one thing, like, you need to keep in mind, the main branch here is read-only mode. So if you want to add it, or you want to make any changes here, you won't be able to do that. So for that, you need to click on create branch, give it a name. Let's say give it dbt concept cells summit. It will create a branch. So like in dbt cloud, there's so many things you can do right away. And now you can see our branches change from main to dbt concept, and it's not in a read-only mode. We can add it here too. Let's quickly glance at the current state of the BigQuery before we start the hands-on models. So as you can see, our project name is dbt training 409. That was the same project which is part of this JSON file we uploaded to our dbt cloud. And here we can see currently it have only one dataset, that is raw. And if we expand this, it have 3 tables in it: customer, orders, and product. If you look into that, so these are like classic customer, product, and order tables, where we have like customer information, product information, and order information. And I'm going to upload these data sets. These are dummy data sets which I created, so nothing to worry, like there is no sensitive or confidential information in here. So the information here is all auto generated, like it's randomly generated by a software. And you can see even we have a credit card information that is like looks pretty same. So and same thing with orders, we have some information related to orders and product. So when I say this raw data set, this is going to be the source. So if we think about the data lifecycle, this is the place where the different sources, let's say a customer system, a product system, and like a place where people do place the orders, those systems have using a data loaders uploaded their data here. So these are the raw data sets. Now let's quickly go to, okay, so also let's briefly touch on the significance of YAML file within dbt. It's important and it's crucial because you will see a lot of YAML files within the dbt project. Even currently I'll show you there are a couple of dbt YAML files exist. I want to touch base on them because I don't want you to get confused down the line or when we are using it. So first I'll start with the profile.yaml. So profile.yaml is a file which is used when we are running things using dbt. So we will need this with dbt core because this file contains the connection details of your data platform. And if, as you can see, when we were setting up things with dbt cloud, we didn't see anything for profile YAML even in our project. If we go to our project, we don't see, let me close, yeah, if you look at this on the file explorer side, you don't see any file with, let me close this just to make it here too, but you don't see any files on the left side, like you don't see any project or profile files. The only file YAML files here, dbt project. And the reason being is we can connect to like our platforms. So for example, BigQuery in this case, directly using the dbt cloud interface. So we don't need a profile.yaml file, but if you are using dbt core, then you might need a profile YAML, which contains the connection details for your data platform. The next file is the dbt project.yaml, which is part of our project too. So this file basically contains settings or configuration related to our project. So it contains like project name, as we can see here, it contains a project name, version, profile, which profile we are supposed to use. Here it's default, but as we say, we have profiles.yaml from where we can get. Then also the directory information, or you can say specify those places where dbt should look for different files. So for example, like if it's a model where dbt need to look into this, so it provide that setting. We can do that setting here. Same thing for snapshot, macros, test, and all those kind of things. And in the end also it also like it have a couple of other things, as like where our compiled SQL files will go. It like we don't at this moment, at this time we don't have to worry about these things, but that kind of information is also configured within this dbt project YAML. And the last thing is we can materialize our models. We're going to talk about in details, but like we can materialize our models here and But if we materialize a model within the model file, that overrides this. But this is like if we want more generic or at project level, we can set up here, or even at like folder levels, we can set up those materializations here. And if you, so this is basically in a nutshell, we can say it is a YAML file which contains the project related information. And in our models, you see there is one file, one second, schema.yaml. So you will see like these kind of files here and there in like model folders or subfolders, or we can say like we will find more of these kind of YAML files there. These files are basically used to describe the schema of your table and the test and documentation for your model. Okay, so we can look at it like currently we have two models, my first DBT, my second DBT model, and we can see a bit of that information like their schema, what column, like for example, one of their column is ID in my first DBT model, what its description, what kind of tests you do. We're going to look into that in more details, but what I'm trying to say here, like other than like the configuration YAML files, we will find these kind of YAML files within the like folders, or like you can say the subfolders of models, or these files basically used to define more specific config settings for the model, like what table name, IDs, documentations, and these kind of information. Models. Models are nothing just SQL files containing select statement. And these are SQL definitions which are then materialized as a table or view. We need to keep one thing in our mind, that the name of the models are created by DBT based on their file names. Let's jump into an example to see how we can create a model and what models. Models are nothing just SQL files containing select statements, and these select are SQL files which are then materialized as a table or views. And one thing we need to know, that the name of the model created by DBT is depend on the file name. So whatever is the file name, that with that the table or view will be created with the same name. Let's take a look of an example of a model. Let's go to our DBT cloud. Okay, awesome. So currently we have two models, which is like example models, but we're going to create another model of ourselves for our understanding. As we know, in our BigQuery, we have in the raw data set of BigQuery, we have three tables: product, customer, and orders. We're going to create a model on them. Okay, so let me go to my. So this is one of the model which I've already created. I'll just copy paste this and explain the same to you. So let's go to our IDE, and here you can see so far we have nothing. So I'll create a new file, paste this, and just save as. The name will be, and the name is important because that will going to be our .sql. That's going to be the name of our model, or name of the table or view in our database. Okay, let's create this. I just want to see where it is. Oh, it is outside. Let's put this as in the example only. Okay, and it's in the same directory, and you see like the color of model and example is changed a bit. It says MM, and here it says add. A. So this is like, you don't have to worry about this. Is like a Git thing because we added a new file. So it says models and example folders are modified and new file is added. Okay, so if you look at into this model, as we keep saying, model is nothing just simple select statement. That's the same we can see here. So this model start with the CTE, where we are not doing too many things here. Or too many transformations we can talk about. Like, we're keeping it simple because this is not a course on the SQL. It's more on explaining the concepts of DBT and how it works. So here you can see we have a simple CTE where we are pulling the customer ID, customer name, email address, billing address from the raw customer tables, and this is the select statement. That's what we are doing in this, and we are using a CTE here. Okay, so now this is our first model. I think like it's very basic. We can now, if we go to our BigQuery, let's go to our BigQuery. So currently in our BigQuery, as we saw, we have only one data set that is raw. It has nothing else. Let me refresh. Nothing in there. Let me run the model. So what to run the model, we just need to pass the command dbt run and it will run our models. So that is very simple. In the dbt cloud, we have the dbt CLI is also, or the terminal is also integrated here, which you can, and that's why I'll, like as I mentioned initially, dbt cloud is have like more functionality compared to dbt core, where we have to manage so many like these functionalities or these pieces by ourselves. So here we don't have to worry about anything. We just do dbt run, click enter, and now this will run all the models we have. So currently we have 3 models, like 2 models from our example folder, and we created another model, stage_customer. And now, like we can see all 3 ran successfully. It was success. We go back to our BigQuery. Okay, let's refresh the contents. And here we can see the data set, which when we were setting up the connection of BigQuery to dbt cloud was created, shows up, and it have all 3 models like stage customers and like other 2 example models here. Okay, I can look into, just preview. You can see the customer name. I think like that's the only transformation was like customer names were concatenating. We can see the customer names are concatenating. And now let's go back here again. And now, so we know like the models are nothing, just simple select statements in there, or we can use these statements to do the transformation. And now we know, like, because like the example which took was kind of simple example, but in real world, like our data transformations could be like very long and difficult to maintain within like one model. So for example, like one model which have all the transformations of customer, there could be another model which contains all the transformations related to product or sales kind of things. So in those situations, it's very hard to do everything within one model. So that's why, like, ideally we should separate our models into different models and reference them using ref. So this is the keyword you see here, ref. So let's look at the example for that too. We go back to our IDE one more time. Let's minimize this and we'll create another new file. I'll close this, create another new file. I'll go to my GitHub because I already created this. I just copy paste from there because these are very simple. So if you paste here, and you can see, let me name this as stage orders. Let's name it as save as stage orders .sql create, and this also created outside. Let's paste it here, put it in the same folder. Okay, and now, so here you can see that we are using the orders and product tables from the raw dataset, but we are referring to the other model. So as I mentioned, when we have like complex transformations, so the best practice is to put them in like in different models and we can refer them. And the way to refer them is like put 2 curly braces, ref is the keyword, and then put the name of your model in the bracket, in parenthesis. Okay, so simple. And after that, if now we want to run this model, we can do again dbt run. But if we do dbt run, like it run all the models, but we don't want to run all the models. We want to run only this model because this is the new model. So let's do s and the name of the model underscore orders dot SQL. Okay, sounds good. Let's click on this and okay, pass. So this is also created. Now we jump to our BigQuery one more time. Sorry, let's go to our BigQuery, click on refresh, and we will have another, sorry, you can see here stage orders are in there. So now we have all models here, and go back here. Yeah, sorry. Yeah, so as we discussed, like we added 2 new models here, and the one was like simple select statement with a CTE, the other one where we want to define the concept of REF, so we can reference one model into another models, and this is like from that point of view, because our transformations could be complex and can exist in different models, so we can reference them. So now and the other thing is like to run a model, the dbt run is a command, but if you want to run a selected models, then do dbt run -s and the name of the model. S means select. Now let's look into the materialization. This is a word you might be hearing from long time in this video. Materializations are basically the strategy for persisting dbt models in the warehouse, and this could be 4 types. One is the view, which is the default, then the table, which build the table on top of it, then the third will be incremental, where we want to add only new records, and the last one is the ephemeral, where we just create CTEs, so no table will be created. And view and table is something whenever we do a model run, they are rebuilt on each run. However, on incremental, this is basically when we run, is like if any new records are there, they will be added only. And the last one is basically a CTE, so no tables will be created. And now let's go back to our IDE one more time. And you must be wondering, like, this guy is saying like the default materialization is view, then how come if we go to our BigQuery, these are tables, these are not views? Because the views in BigQuery have a different sign. So for the reason for that is our project file, the project YAML. So let me open this dbt_project YAML. So if you look at this table, this YAML file, which have like a lot of configurations related to the project, at the end it says like we can even like set the materialization default. When I said not default, sorry, like we can set the materialization at project level or at a folder level within this file. So if you look at this, it's like it says model, my project. So anything under example folders will be materialized as a table. Okay, so that's the reason like everything we created, like all the models we created, are materialized as a table instead of view, because we have a setting here. If let's say if it was not there, everything under models would have been a view. Okay, so let's create another folder, like just to show you. Let's do one more thing, because everything under example of models stays like that. Let's create another folder here. Let's create a folder, we name it as view. Okay, click create, and we will add another file here. Let's do this. 1 second. Okay, cool. Let me close this. My system was a bit slow. I'll go back to my I'll go back again to my GitHub just to copy the model. I'll copy this, come back. Okay, let me paste this here, and we'll save that as v underscore customer dot SQL. Okay, create. Okay, awesome. So now, like, it must be outside. Let's put this in the view folder. No, I think I put it in the wrong place. Oh no, I put it in seeds. So let me move this to view. Okay, now it's in the view. Okay, so if you look at this, it's a simple same select statement which we had for our stage underscore customer.sql, but here we are adding this setting at the top, and you will be like, Anand, you said that like the default setting is view. Why we have to specify here? Okay, I'm just to let you know there are like two ways to materialize our models as a view, table, or the things which or like different types which we talked about it. The one is like at the top of your model, like at the .sql, like at the top of your SQL file, you can define what kind of model you want. So this will get the highest priority. Even let's say if we go back, I'm just saying like if we set something here, like in our dbt underscore project.yaml, that like any settings or any configurations within the model override this. Okay, and here it says apply all the files in the models and example, but our v underscore customer.sql is not there, so I'll just remove this. But I kept it here just to show you that in case if we are part of a folder which is materialized as a table in dbt underscore project.yaml, then we have to add this line to override that. But if we remove that, still we should be able to create a view. Let's save, and I'll run this again. dbt run. We don't want to run all the models. What we'll do as v underscore customer dot SQL, enter. Okay, this is successful. Let's go to our BigQuery, and now if we refresh the content, and you can see here the view is different. So these are tables. Now we created the views. Okay, so let's go back to our IDE one more time. Now we know how to create a view. What is a view? Oh, sorry, what is a model, how to create it. The naming conventions are also, like as I said, the file name. If you look at this, v underscore customer.sql, that's our model file name. And if we look, come to our BigQuery, that's our view name too. So the model name, a model file name will become the model name in BigQuery. Like we can look at this stage underscore customer.sql, become here a table stage underscore customer. Okay, that's another thing to keep in mind. The last thing I want to talk about in models is we briefly touched based on that, but I just want to show you. So if you look at this folder, we have a schema.yaml, and if you remember, this is we can have like these kind of YAMLs in different folders of folders and subfolders of models, where we can define like schema of the table, some test, their documents and all that. We can see here is like basically like for our default models or example models, they already have like, okay, this column ID, there are two tests. We're going to talk about test in detail, but this kind of information persists in these YAML files. So just keep in mind, like when you are creating your folder structures and models, just keep in mind about the YAML files too. For example, I know like we haven't done a very great job in terms of like keeping the models separate. Like for example, these staging customers could go in a staging folder within the models, and it can have its own like YAML file. That could be the way. So like I'm not too focusing on like how to keep the folder structure of models, because like it depends on use case. It depends on what you're trying to do, but there are some standard practices or good practices which you need to, like staging tables should go under staging, views should be under views, then the final aggregated tables can go into like a folder name aggregated, or even like marts, and there you can have different departments. Those kind of things you can put it here, and in all these you can have YAML files specific to those folders. Macro. dbt macros are pretty much like a function in any programming language such as Python or Java, where like we write functions so we can use that code again and again and again. So it's the same concept here, where we are simply writing the SQL codes that can be reused across various models. And as I mentioned, like it's the main purpose for macro is code reusability and to make our work efficient. If you look at the screen, so on the left side we can look at the syntax for creating a dbt macro, and which is looks pretty straightforward, where we have the curly braces start with percentage, then macro name, then number of arguments we're passing. So that's like from here to here it looks like a function name and the number of arguments you're passing, and then percentage, curly braces, and the SQL logic for our macro, and then closing the macro. Like because the dbt is built on Zinzer, so that's why you are seeing this kind of format, but like it's a syntax you can think from, like it's a dbt syntax, nothing to worry about like why we have to put this curly braces in, but it's because it's not that too complex. It's basically like the things we need to keep in mind, like macro name, then the name of the parameters we pass, and then close it, and the SQL logic for the macro we want. And on the right side we will see how to call this or how to use this macro. This is also pretty straightforward, the macro name and the pass the arguments. So let's look at an example and let's look macro in actions. So let me go to my IDE. So currently if you see, like we have nothing in our macro, and you can see like all these are highlighted as M. So that's because of the Git, like these files are modified and added. Let me do one thing before we look into the macro. Let me commit this. So as we can say, these are models updated. Commit the changes. So it will push all my changes from my local to my branch in GitHub. Okay, let me close this. And now for macro we don't have any folders, or like we don't have any macro here. So we'll create a new file here. Okay, and let me go to my GitHub where I already have a macro written. So I'll copy this and paste it here. Okay, and I save it as getparts.ca .sql create, and I guess I'm doing this again and again. I need to put this in macro. Okay, and now let's look at this macro. So one thing before we look into the like what this macro is doing, but if you look at the syntax, it starts with curly braces, percentage, macro, the name of the macro here, and number of parameters. So we are passing only one parameter, then percentages, and this is the select statement in between, and this is like we are ending the macro. So this macro is a pretty straightforward macro. This macro is basically doing nothing. It's fetching the date parts. So like whatever date pass that will be considered as origin date, then we are fetching year, month, day of week, day of year, week, quarter, those kind of information. And if you look at this, we have at line number 3, select struct. Why are we doing this? Because the macro is like it will return a single value. So to return a single, like because we have so many parts in the dates, so to return them as a single value, we need to define them as a struct, and all these functions are related to BigQuery. you probably can do the same thing in a different way in different data warehouses. Like for example, year could be a direct function. Like you could have a year and the date name to get the year. But this is the format here you are seeing is more from BigQuery, and because they will be returned as a structure. So a structure will contain all these values. Struct is a concept in DBT where to contain multiple values in a single field. Okay, so now we have this. So next thing we need to do is we want to use this macro. Okay, to use this macro, we'll create another SQL where we will use this. Okay, let me go back to my my GitHub. I'll copy this. So I already have one. I'll just copy this. Okay, I'll create another file and paste it, and looks like, so it's pretty same as what we have in other model. It's just in line number 11 we are using the date underscore parts macro. So we creating a model which calling a macro, and data is a very good example. Like there could be different models or different situations where we want to extract the different parts of the dates. So this example, this macro like fits pretty much in a lot of use cases. So we'll save this as let's give it a name, macro.sql. We want to store this in models. Let's save it in example. Okay, so now we can see we created another macro, and the name is macro, which is not very good naming practice, but just for our understanding we put that way. Let's run this. dbt run macro.sql. Oh, so I need to select this. Yes. So now what we're doing, we are running this model, and in this model, if you like, it's what we're doing in line number 10 is basically we are calling a macro to extract the date part as structure. Rest of the things are pretty straightforward, which we have discussed so far. So let's run this. Click on this, click on run. Okay, that's wonderful. It ran successfully. Now we go to our BigQuery to see. So that should be created as a table because it's part of example folder. So anything under example will be created or materialized as a table. So go here, let's click on refresh. Okay, we can see macro table is created. If we click on this, and you can see it is a record, which is basically a struct, and you expand, you will see all these values here. Or if you want, we can preview this too, and you will get the idea how the, so you see, so everything is stored as, like, they look like individual folders, but if you want to extract them, it will be like whatever is the field name, data underscore extract dot, or this, and it's the same thing. Like, one second, let me expand this. So you see date underscore extract year, date underscore extract month, these kind of things. This is a struct format. Okay, so that is all about macro. Macro is just piece of code which we want, which we know going to use in multiple places, pretty much like a functions in OOPS programming. So we will define that there is a syntax for it. We follow that syntax, write SQL statements, and there is a syntax, or there is a way of, there is a syntax to call it, and we call it, use them accordingly. So that give the code reusability in DBT. DBT test is a way to test the data quality of your models. And there are like two types of tests in DBT. One is generic test, and the other one is singular, or you can say more customized test. So in generic test, we can check the uniqueness, not null, accepted value, and relationship test per column in a YAML file. So for example, if you look at the screen on the left side, we have a schema.yaml file. In that, in our first model, which has the name of the model is my first DBT model, the column ID should be unique and not null, and same thing goes for the my second DBT model. So basically, generic test we define within the YAML files stored within the model directory. So these are the YAML files which we talked before. Is like these are important YAML files. They consist the schema information, documentation information, and the test, like generic test. And these are like 4 types: unique to check the uniqueness, not null if there is no value, like it has to contain some value. It can't be not null, some accepted values. So for example, let's say in country, like you can have certain countries. For example, your business is in, let's say, North America, so you can have only like United States of America, Canada, or Mexico in your countries. So that could be an accepted value. And relationship, like primary and foreign keys kind of things. Now we talk about the singular tests. So singular tests are sometimes called like one-off test, or you can say more customized test. And this is like, these are important in sense, like because a lot of these generic tests are good to check the values of certain columns, but they does not fit for all the situations or all the business rules. So in that situations, we have to switch to singular test. So in singular test, basically we write SQL scripts, and those SQL scripts reside under the test folders, and basically these are SQL queries. And the concept here is like when we run DBT test, and if they like these tests are considered successful when they do not return any row. Even if they are returning one row, that means it's unsuccessful. That's how like these tests are considered. And these are like 2 types of tests, but you can go beyond that. Like there are some packages and all things are available to, if you want to perform more tests, but these are like you will find out of the box tests. So generics are out of the box. Singular is like, it's a concept where you can write your customized SQLs to test your data quality, or to test to check your data. And here the concept is like, if we get any records, like the test is successful only if we don't get any records. Okay, so let's quickly look into them. I'll go to my my GitHub. I copy this is one of the tests. I'll go back to our IDE. So currently, if you look at this, let me close this. So currently we don't have any tests under test folder, and if we go to models, we have a YAML file which contains 2 tests. So basically, for the example data model, there is the first example data model, there is a test for ID, like it has to be unique and not null. And for the second model, it's the same test. So but we don't have any customized or singular test. So what we're going to do, we're going to create a new customized test, and which I copied from GitHub. Let me create a new file, paste it here. Okay, let me change the name. Instead of sales, we have orders here. Okay, so let me save this. No orders today. I'm just giving a name just to trying to make it more intuitive. Let me save this and test, create. Okay, awesome. Let me explain this test. What we're doing here, we basically we have one table stage underscore orders. So in that, we are checking if do we have any orders for today, because let's say hypothetically we run this job every morning. So in that scenario, we should not have any orders of today. If that's the case, we should then our test should fail, and we need to look into why this is happening. So here the query is simple. We're doing a count on, and we calling as number of orders today. We are referring to our stage orders table where we have a order date. We checking if it is current date, and the count, and checking the count. It should not be greater than 0. Basically, if we have any, what it means, so like if we have any order for today, it will return that row. Like it will return a number, not row. It will return, let's say 2, 3. But if it does not have any order for today, it's not going to return even 0. Okay, because we have this condition, heavy count is greater than 0. So it won't going to return even 0. So I just want to give you a quick look of the stage orders so you understand what I'm talking about. So if we go to our stage orders, and you can see we have like order ID, customer, and then we have an order date. And if we go on preview, it's basically the order date. And as I mentioned initially, this is like made up data. I know there is no order for today, but we are practicing this test. Okay, let's go back to our IDE. So now we have 2 tests, or I'll say 3 tests. One is this singular test where we are testing if is there any orders for today, where we are simply checking if order date is equal to current date and is there any records, any count for that. And there are 2 generic ones, which is part of our schema.yaml files, where we're checking if ID is equal to unique and not null. Okay, so to run the test, we just need to put dbt test. It will run all 3 tests, and we'll see how many of them fail or pass. Just click enter, and awesome. So you can see here we have 1 error and 4 pass. So basically there were like 5 tests, 5 tests in count. Like how we will look into how it's 5 tests. If we go to our schema.yaml, okay, cancel. If you look at this, so for this ID, we have 2 generic tests. One is for uniqueness, another is for not null. And same thing for here, uniqueness and not null. And so these are count as 4 tests. And the 5th one is our no orders for today. That was the customized one. And if we look at the log, 1 second, so 4 got passed. So our no orders for today got passed. Not null, second DB got passed, unique got, but 1 got failed. So one which got failed is that in my first DBT order, there is some null values. We can check that. Let's go to our BigQuery. And if you look at this, these are the dummy models or the example models which came out of the box when we initiate the project. And if we preview, oh, that's interesting. You have 2 records and one of them is null, and that's why not null is failed. And it is done intentionally to show you that what happens like when you run dbt test. It tells you, I know like here it says failed, but we can look, there were total 5, 4 got passed, 1 got failed, and now we can look into this. Okay, okay, 1 record is null, so that's why it's not passing test. Okay, so that is all about test. Now let's go to snapshot. This is a very interesting concept of snapshot. Before we jump to the dbt snapshots, I just want to give you like a background. Snapshot is basically to capture the changes in your data, and when we say capture the changes, these are we talking about slow changing dimensions only. And slow changing dimension is a concept in data warehousing that refers to the ways in which data changes over time. And these are slow changing dimension. These they are called slow changing because the changes which we're talking about usually happen infrequently. It's not something which change very frequently. So example could be like a customer address, or other could be customer phone number, these kind of things, or product price. In some cases it could be slow changing dimension too. In dbt, so snapshot capture the slow changing dimension, and slow changing dimension can be of various types. Like it could be type 0, type 1, type 2, I think till type 6 it goes. But dbt only captures slow changing dimensions type 2. Okay, where we just keep the history and add new information. Like understand, type 2 is where we keep the keep the history, means we keep the old record and the new record, and we will show you how it works. Okay, snapshot model in dbt is a special kind of models, as I was talking about. Like it tracks the changes in your data over time. To create a model, we need to create a file in the snapshot directory. So if anything is not in the snapshot directory, it won't know like it's a snapshot. And that file should contain a snapshot block, which we can see here on our screen. Like in both examples, like it started pretty much like the macro, like curly braces, percentage snapshot, name of the snapshot, percentage, and then end of snapshot. So in both places it's pretty same. And there are like two strategies to create these snapshots. So one is called timestamp strategy, which is the recommended strategy, and second one is the check strategy. So the timestamp strategy is used when the data, or like one of the source tables or data, includes a timestamp column. So basically that's get updated when records change. So we can use that timestamp to track the changes. And on the other hand, the check strategy is basically it is used to track the changes in the value of a specific column. So in like the major difference between both of them is like timestamps look at the like one of the like timestamp strategy look at the timestamp field to see if any of the records has changed, where like check is basically check the value and check the value in the column to see if the value got changed. Okay, so now if you look at this if you look at the timestamp strategy example, check strategy, they look pretty same, only like the configurations, few things change. The first thing is target schema. It's always a good practice to create a separate schema for snapshot. Like you can use an existing schema, like for example in our case staging and all, but it's a good practice to create a new schema. So target schema is a snapshot that will create a, if it doesn't exist, it will create a new schema in our data warehouse. Strategy, that's like which defines what strategy you want to use. So here our strategy is timestamp, this is a check. Then we talk about the unique key and the updated at like the field on which the timestamp need to check when a record change, like an that gets updated when a record change. Here like the values, we the columns need to check where their values got changed, and this is the source tables from where on which we are applying these snapshots. Okay, let's go and look into the example of snapshot. I'll go to my in my GitHub first, and let me go to snapshot, copy this. Let me go to IDE. I'll add, let me close all this, and I'll add the file here, the snapshot file, and I'll explain which one we are using. So here you can see like line number 1 and 14 makes sense. This is the base table from which we are taking, and in the configurations you can say, okay, we are creating a schema named snapshot. Strategy we are going to use is check, and the unique key is the customer ID, and we are checking for the columns address. Okay, so here we're going to check the values of the address, and the unique key is the customer ID, and we're going to use the customer as a base table here. Okay, let me name this properly. Copy this, let me save this with the same name, and it has to go under snapshot folder, under snapshot folders. So let me go put it in a snapshot, create. Okay, let me close this. Okay, so basically if we try to understand this in simple words, basically what this snapshot do, if any value in the in the address will change for customer ID, it will create a snapshot. And for the snapshot, we have to run the snapshot every time, otherwise we won't see the changes. So what other thing we need to keep in, when we run the snapshot, it will add extra columns. That's the slow changing type 2, where we add the extra columns to track the changes. So what we'll do first, we will run the snapshot without making any changes, and we'll see what happens. Okay, so we'll do dbt snapshot. Okay, it's running. I'll go to my BigQuery. Let's go to my BigQuery. I won't refresh. I just want to show you currently, if you look at this, we don't have a schema name snapshot. Okay, so this was successful. The address snapshot check was successful. We don't have snapshot schema here. That's one thing. Second thing, I just want to show you in the customer table. I just want to give you a quick preview. So customer ID was unique, so that we said, and the address was the other thing, which address, we keeping a check on the address values. That's what a snapshot is doing. So when we run our snapshot for first time, or we already did that, so it will create a snapshot table in the snapshot, it will create a table with the name address snapshot check in the snapshot schema, with some bunch of extra fields which keep track of these changes. So let me do a refresh here. If we do a refresh, so you see now we have a snapshot, an extra schema. If we expand this, click on this, and because our query, let me show you what was our query. Let me cancel this, sorry. So our query was basically everything from the customer table. Okay, and if address change in the customer table, please create a snapshot of it. So currently this is our first run. There is no change in the address. If you go and check, we observe there are 4 new fields, which is what is the dbt source ID when it was updated, valid from 2. Okay, this is our first run, and the valid 2 will be null because we haven't made any changes. Now what we will do, we will update the address of one of the customer, and then what will happen, it will create 2 records. One will say is valid from till date, and the second one will be null. Okay, let me do this, and I'll copy very quickly and go here. So very quickly I'll copy the update statement too, because I have handy. I don't. So I'll copy paste this, C. Don't worry about this. Let me show you what is it. Okay, so we are what we're doing here basically. I'll remove this. So what we are doing here basically, we are updating a raw table, the address of one of the customers in our raw table. So this customer ID is this 1827. We are setting the address to this, and this is our raw table. Okay, so let me do this. Let me run this. Okay, awesome. So the address of this customer is changes in the raw table. Okay, but if we go to our snapshot, one second, let me go this. if I do this, and I want to do one more thing here, I just want to check the address in the customer table too. So if we paste this here, so we basically, what we're doing here is we are, one second, sorry, we missed, did we missed? Looks like we missed it. Yeah. Select star from, okay, cool. So if you see here, we are basically checking in, okay, there is another mistake here, typo is there, it's customer. And let me delete this. Okay, now it looks good. Select star from this, this. What's the outcome of this? So you see, this is the customer, and we updated the address to 54 Brighton Road. And if we go to our snapshot, keep this in, like when we haven't run the snapshot again, so currently it should have only one record. Oh, my bad. The name of the table is address, not the. Okay, if we run this, currently it will give only one record. Okay, and that's and now what we'll do, we'll run the snapshot again and we should see two records. Now before we make the change, I think there is the address was the same. I need to change it. Let me do this. Sorry, my bad. And we do 55 or make it this. Okay, we'll update this. So I updated accidentally to the same address. So this says one row modified. If we go here, click on run, it will give us one record, and here we see the address of 54 Brighton Road. But if we look at the snapshot, like run this, it will have only one record and it will have all 54 Brighton. Okay, so now what we need to do, we need to run the dbt snapshot again. Like once this is done successful, we will do a select statement and it will show you two records. So that means it will capture both changes. Okay, now let's go here and run this. Okay, so now you can see there are two records and the one record is null. That's the current record, but this is like when this record got updated is this. From here we know like when this record got updated, and this is the check strategy. So if you go and look at the addresses, so old address was 54 Brighton, now this is 5455 Brighton Road. So let me go back. So that's pretty much for dbt snapshot. All right, so that's all for this dbt video. So in this video we learn what is dbt, where it fits in the data life cycle, the various files used in dbt, core concepts of dbt such as models, snapshots, macros, and test. And in the end we do hands-on on all of these core concepts using dbt cloud with BigQuery. So that's all for this video. Stay tuned for upcoming videos where we're going to explore more features of dbt and how we can use it with various data architectures. Thank you.